You are in the water. It's dense, viscous, with visibility almost zero. The only sounds are your strained breathing and a distant, unintelligible screech. Oxygen is so scarce here that each breath feels like trying to inhale at the summit of Everest. Your lungs burn, your brain begins to fail within minutes. Around you there are no coral reefs, but an alien landscape, carpets of primitive sponges and algae. In the murk, shadows of creatures unlike anything alive today flicker. Then, slowly emerging from the gloom, a silhouette appears. First, two enormous, spiky appendages, then a pair of complex compound eyes, each the size of a human fist. They turn and focus on you with the indifferent precision of a predator. You realize you are not an observer. You are food. This was Anomalocaris, the planet's first super predator, but it presents us with the first paradox. Why did the ocean's most dangerous hunter specialize in cracking open armored trilobites when there was plenty of defenseless, soft-bodied prey around? This violates a basic law of nature. Why expend maximum energy on the most challenging target? And a second, deeper question. How did such an incredible diversity of complex predators and prey suddenly appear in the ocean, when for hundreds of millions of years prior, life remained primitive and almost motionless? This leap was like water, seeping through rock for centuries, suddenly transforming into a powerful torrent carving a canyon. The answers to these questions are the keys to the survival code in the strangest world that ever existed. By the end of this investigation, you will understand three fundamental laws of predation and defense that shaped you too. In just 3 minutes, you'll see how one man's discovery in the Canadian mountains overturned everything we knew about the tree of life. This leap in life's complexity is called the Cambrian explosion. It sounds like a moment of creation, a triumph of evolution. It's commonly believed that within a tiny window of 20 million years, after nearly 3 billion years of stagnation, all major animal body plans suddenly emerged, from arthropods to our chordate ancestors. It's a beautiful story, and it's incorrect. The numbers paint a different picture. Over 90% of all species found in those Canadian mountains went extinct without leaving descendants. This wasn't a fireworks display of life. It was an explosion at a testing ground where almost all prototypes proved unviable. This explosion generated not so much diversity as it did the planet's first total confrontation. The first eyes appeared not to admire the world, but to see a threat. The first carapaces, to avoid being eaten. The key to this brutal world was found almost by accident, and the discovery was so strange that it initially provoked only laughter. On August 31, 1909, paleontologist Charles Doolittle Walcott stumbled upon a slab of shale at 7,500 feet in the Canadian Rocky Mountains. On the stone, he saw a perfect imprint of a soft-bodied creature. It was a window into an ancient world, the greatest paleontological stroke of luck. Walcott was convinced he had made a breakthrough. But when he presented a reconstruction of one of his creations, Opabinia, at a scientific conference, the room erupted in laughter. A five-eyed creature with a clawed proboscis didn't fit into Darwin's neat tree of evolution. It looked like a mistake of nature, a ludicrous fantasy. For decades, his findings languished in archives. Only a new generation of scientists realized Walcott was right. He hadn't found the ancestors of modern animals. He had found true aliens from another world who lost the evolutionary race. Have you ever been in a situation where your correctness only provoked ridicule? Now that we know the Cambrian Ocean was a battlefield, let's conduct a thought experiment. Imagine you are evolution. You have 3 main developmental paths for a new creature. You can invest resources in impenetrable armor, like trilobites, in incredible speed to escape any danger, or in perfect camouflage to become invisible to predators. Which of these 3 paths seems most advantageous to you? Write your choice, armor, speed, or camouflage, in the comments right now. Trust your intuition. In Section 7, we will return to this question, and you will see which choice actually led to survival and which led to guaranteed demise. The answer will surprise you. But to understand the logic of defense, you must first study the weapons of attack in detail. What caused all ocean dwellers to frantically grow spines and carapaces? Clearly, in this new world, someone set the rules. Initially, paleontologists only found scattered parts, fossils resembling a shrimp appendage, a round oral disc like a jellyfish, and a body like a primitive worm. It seemed these were three different animals, each occupying its modest niche. But in the 1980s, scientists realized that all these parts belonged to one creature. Imagine finding a hammer handle, a knife blade, and a corkscrew, thinking they were three separate tools, only to later realize they were parts of a single ancient Swiss Army knife. Its name is Anomalocaris, meaning unusual shrimp. The name itself is a monument to the initial mistake. It wasn't just a predator, it was the planet's first complex weapon system. To understand its power, we must dissect this system. The first part of this system misled scientists for decades. How could one monster be mistaken for three different creatures? This error wasn't a sign of incompetence, it was a symptom of how alien this life was. Its grasping appendages were thought to be the body of an anomalous shrimp. Its circular mouth was taken for a separate jellyfish species called Pikaia, and its enormous body was classified as a primitive sponge. It seemed this trio coexisted peacefully. But in 1985, paleontologists Harry Whittington and Derek Briggs assembled the puzzle. The shrimp turned out to be its arms, the jellyfish, its mouth, and the sponge, its body. The ocean didn't contain a collection of modest inhabitants. It contained an alpha. Its oral apparatus, resembling a pineapple slice with sharp plates, worked like a nutcracker. It couldn't fully close, it was designed for breaking. This weapon was deadly, but to use it, a victim first had to be found in the murky water. For this, Anomalocaris had its own high-tech radar. How did it track prey where there was almost no light? Most Cambrian animals had only primitive light-sensitive spots. Hunting, it seemed, was done by touch. But Anomalocaris was an exception to all rules. Its complex compound eyes were a marvel of engineering. According to the latest estimates, each eye contained up to 16,000 lenses. A modern housefly has only 3,000. This means Anomalocaris possessed some of the sharpest vision of its time, possibly in the planet's entire history. It was a sniper in a world of the blind. Such vision allowed it not just to notice movement, but to assess distance, speed, and the vulnerable points of armored targets. Its vision allowed it to choose victims, and its main weapon was to crack them open. What exactly did it use to kill? Its two powerful, spiny frontal appendages looked like a versatile weapon for tearing soft flesh. This would have been the most logical and energy-efficient hunting method. However, biomechanical modeling showed that these appendages were too fragile for crushing blows. Their spines were directed inward not for tearing but for securely holding. They worked not like fists, but like human hands bringing a walnut to a nutcracker. They were utensils for positioning prey before its crushing mouth. It was this highly specialized weapon that launched the first arms race. The evidence remains in the stone. Trilobite carapaces bear characteristic W-shaped bite marks, perfectly matching its jaws. But Anomalocaris was not the only nightmare lurking in that ocean. Anomalocaris was a perfect killing machine, advanced vision, specialized weaponry, and enormous size. It established the law of force in the Cambrian world. But evolution never puts all its eggs in one basket. While one species developed brute strength, others sought asymmetric answers. The pressure from such a super predator forced life to experiment with the most bizarre forms imaginable. There were other hunters whose anatomy defied all logic, and there were victims who transformed into walking fortresses, more akin to a hallucination. Imagine a creature with 5 eyes on stalks and a proboscis with a claw. Sounds like fiction? In the next section, you will see it with your own eyes. Can an animal have 5 eyes and a proboscis with a claw at the end? It was precisely this question that made scientists laugh when they first saw a reconstruction of Opabinia. Its body, consisting of segments with lateral lobes, resembled a whimsical swimming worm. But then the details shatter this picture. On its head were not 2 but 5 eyes on flexible stalks, providing a panoramic view. From beneath them grew a long proboscis, almost a third of its body length, with a claw at the end. With this claw, it grabbed prey from the seabed and brought it to its mouth, which was located under its body and, most strangely, faced backward. This design seems absurd, but it was an ingenious solution for hunting in murky, bottom-dwelling environments. The stalked eyes allowed it to scan the horizon for threats without interrupting its search for food. But if Opabinia was a strange predator, one of its potential meals looked so improbable that it was named Hallucigenia. What would you have to find in stone to name it Hallucigenia? The first reconstruction, made by paleontologist Simon Conway Morris in 1977, depicted a creature that walked on 7 pairs of sharp, rigid spines. On its back, it had a row of tentacles, which were supposedly used to catch food. This image was not just strange, it was incorrect. For over a decade, scientists believed this creature walked upside down. Later, it was discovered that the spines were not legs, but protection on its back, and the tentacles were its actual legs. Then it turned out that what was thought to be its head was actually its tail. This series of errors is not a failure of science. It's proof of how alien the logic of Cambrian life was. Its spines were an almost perfect defense against predators like Opabinia, making any bite painful and dangerous. These creatures weren't just strange, they were part of a vast evolutionary graveyard. Why did evolution create such monsters? Intuition suggests it should strive for perfection, for more logical forms. The Cambrian period was a field for blind experiments. Ecological niches were empty, and life tried everything: 5 eyes, spines on the back, proboscises, circular mouths. It was an explosion of inconceivable designs. But it wasn't a creative festival. It was a slaughter. Over 90% of all these experimental species went extinct, leaving no descendants. These were dead ends, like the Vetulicolians, forever erased from the book of life. We live in a world built on the ruins of these failed projects. Our distant ancestors, small and inconspicuous chordates like Pikaia, survived not because they were stronger. They survived because they were too simple to attract attention. Evolution didn't work like a gardener. It was like a forest after a fire, where thousands of different sprouts emerge from the ashes. Almost all of them perish in the struggle for light, leaving only a few accidental winners. This practice of wild experiments led directly to the only possible outcome in conditions where the planet itself was toxic. Opabinia and Hallucigenia were not exceptions to the rules. They were the rules of the Cambrian world. Their absurd appearance was the only functional response to unprecedented predator pressure. But this pressure didn't just come from other living creatures. All these strange forms were a response to 2 global threats: constant warfare with each other and the hostile chemistry of the planet itself. Even if you could evade Anomalocaris, you would face an invisible killer that armor couldn't protect against. Why couldn't they simply escape to shore to flee predators? Because the air was poison. The logical escape from this bloody melee was land. No predators there, no murky water. At first glance, it seemed a safe haven, but the reality lay in the numbers. Atmospheric oxygen levels were only 12.5%. Today, it's 21. This is the air at an altitude of almost 5,000 meters, the so-called death zone in mountaineering, where the human body begins to die. For you, this air would be a slow-acting poison. Within minutes, severe hypoxia, brain failure, loss of consciousness. A weak ozone layer offered no protection from harsh ultraviolet radiation. Your skin would burn in minutes. Land was not salvation, but a crematorium. But if there was so little oxygen on land, what was happening in the water, where by definition there was even less? Okay, so there's no air to breathe on land, but life thrived in the ocean. It would seem that this problem didn't exist there. This is a misconception. Oxygen concentration in the water was critically low, imposing severe limits on metabolism. The Cambrian Ocean was a world on the verge of suffocation. Most of its inhabitants were sluggish, almost sleepy, to conserve every molecule of energy. And here arises a new paradox. How could Anomalocaris exist under such conditions? A meter-long, active predator with enormous eyes, requiring colossal amounts of energy. Its existence violates all rules. It was like a bright bonfire, miraculously burning in a room where there was almost no air left. Have you ever felt short of breath in the mountains or during intense exertion? Cambrian animals lived in this state constantly, but the lack of oxygen was only part of the problem. One might assume that other differences in the ancient ocean came down to temperature or salinity. These are important but not deadly factors. Geochemical analysis of bottom sediments paints a different picture. The water was supersaturated with calcium and magnesium ions. For modern cells, such a concentration would be toxic. Survival here was not only about escaping predators, but also a constant biochemical war with the environment itself. And this leads to a shocking conclusion. The first shells were not just armor, they were exosuits. Their main task was to insulate delicate tissues from the poisonous chemical soup in which they swam. This hostile chemistry, operating at the limits of possibility, forced evolution to create not only successful species but entire lost worlds. So, let's gather the evidence. The Cambrian world was a chemical prison. The air on land was poison. The water in the ocean was a toxic, oxygen-poor solution. This dual pressure, predators and chemistry, acted as a ruthless filter. It weeded out not only the weak, but also those that were too complex, too large, or too energy-intensive. This is why most of the astonishing creatures we've met ended up in an evolutionary dead end. They failed not because they were poorly defended, but because their biological model was unprofitable in this harsh world. We admire the strength of Anomalocaris and the strangeness of Hallucigenia, but the true winners were those they didn't even notice. In the next section, we will meet our true ancestors. Logic suggests that evolution should build on success, but the fossils from the Burgess Shale show the opposite. Why did almost all these complex, perfectly adapted organisms disappear without a trace? Was it a total failure or a brutal culling? It's easiest to dismiss them as failed experiments, as evolutionary errors too strange to survive. This is a convenient theory. Natural selection simply weeded out the weak and unviable. But the reality, frozen in stone, refutes this idea. Over 90% of the species from the Burgess Shale went completely extinct, and many of them were not weak. They dominated their environment. They were giants and masters of survival. Evolution is not a ladder of progress. It's a branching tree from which almost all branches were ruthlessly pruned. If the successful died out, then who and why took their place? The real reason lay in one of the strangest creatures, resembling a hybrid of two different worlds. How close were we to not existing at all? The history of life could have taken a completely different path. Imagine a world dominated not by vertebrates, but by the descendants of an entirely different group of animals. Look at the vetulicolians. These creatures were promising candidates for the ancestors of all living things. Their segmented body, resembling a hybrid of an arthropod and a fish, was complex and possessed clear advantages in the Cambrian environment. By all accounts, they should have won. But while the vetulicolians were developing their complex anatomy, our true ancestors existed in their shadow, primitive chordates like Pikaia. They were inconspicuous, small, worm-like, without armor or weapons. They should have lost. Vetulicolians turned out to be an evolutionary dead end, while the unassuming Pikaia, only 5 centimeters long, gave rise to all vertebrates, including humans. Its victory was not predetermined, it was accidental, and the key to it lay not in strength, but in an entirely different quality. Anomalocaris, the supreme predator of the Cambrian, left no direct descendants. How could the strongest player on the field lose in the long run? What truly determines the winner in the game of evolution, if not brute force? Consider 2 strategies. The first is hyperspecialization. Anomalocaris and Opabinia were perfect machines, honed for specific tasks, cracking shells or hunting with a proboscis. In the stable conditions of the Cambrian Ocean, this strategy was incredibly effective. But hyperspecialization is a trap. The slightest change in climate, the disappearance of specific prey, and the perfect machine becomes useless. At the same time, the simple body plan of our ancestors allowed them to adapt to any new conditions. It was not the strongest who survived, but the most adaptable. Anomalocaris's hyperspecialization was like a corkscrew, a perfect tool for one task, but useless if you need to open a can. Our ancestors were weak, but their internal rod, the notochord, proved to be a more promising innovation than any armor. This selection was not caused by chance, but by a global conflict. So evolution is not linear progress, but a battlefield of ideas where most projects failed. The survival of our ancestors was not accidental. It was the result of passing through the crucible of this conflict. The competition between specialized predators and generalized prey was not quiet. It escalated into the planet's first arms race. This confrontation became the main engine of evolution, forcing some to develop armor and others to invent new ways of survival. This global war of exoskeletons, spines, and jaws is not just an interesting episode from the past. It is the culmination of the entire Cambrian period, and it is the key to understanding why the animal kingdom looks the way it does today. This war left scars that can still be seen today, 500 million years later, if you know where to look. Why did the strongest armor not save, but rather attract predators? Logic suggests that Anomalocaris should have hunted soft-bodied, defenseless prey, yet it systematically expended energy to crack open trilobites. This was the world's first arms race. The prey grew armor, the predator developed stronger claws. But the reality was not just a race of brute force, it was a technological war. Anomalocaris was not just brute strength, but a specialist in breaching defenses. Its appendages and mouth were tools perfectly fitted to the anatomy of trilobites. Biomechanical modeling shows that its grasping appendages could exert pressure comparable to a hammer blow concentrated on the tip of a needle. Each new iteration of trilobite defense provoked a new iteration of attack development in Anomalocaris. This war of technologies forced victims to invent something entirely new. Where is the evidence of this war? How can we prove these battles occurred? Passive defense is obvious: spines, thick carapaces. Victims looked like passive fortresses awaiting siege. But trilobites invented something revolutionary: active defense. They learned to curl into a virtually invulnerable ball, hiding their soft underbelly. This requires a complex nervous system and musculature. It's not a reflex, but a behavioral strategy. And we have irrefutable proof. Fossils bear scars. On the carapaces of trilobites from the Chengjiang Formation, characteristic W-shaped bite marks are found, perfectly matching Anomalocaris' jaws. Some of these scars are healed, meaning the victim sometimes survived. But this war produced not only scars, it created what you are using to watch this video right now. What is the connection between trilobite shells and your eyes? One could say that the predator-prey principles established then are still at play today. However, the reality runs much deeper. This war was a factory of innovation. To survive, one needed to see the enemy from afar, leading to the development of complex eyes. One needed to chase or flee, leading to the evolution of limbs. One needed to process information and make decisions, spurring the development of the nervous system. Unbeknownst to us, we are veterans of this war. Your fight-or-flight instinct is an echo of the fear of small creatures hiding from Anomalocaris. This arms race was like the first spark in a dry forest. The fire has long since died out, but the entire modern landscape of life was shaped by that primal blaze. We have passed through the fire of the world's first war for survival. We have seen how the pressure from predators and the resistance of prey gave rise to the biological complexity that defines life even today. Now we have all the keys to the Cambrian survival code: a chemical prison, an explosion of failed prototypes, a gallery of specialized monsters, the failure of the strongest, and finally, an arms race. These are not isolated facts, but parts of a unified system. Now that we have all the elements, we are ready to assemble them into a complete picture and deliver a final verdict. At the very beginning, we asked several questions. In the final section, we will answer each of them. Now that all the puzzle pieces are on the table, we can assemble the complete picture. The Cambrian world was not chaos. It was a perfectly tuned system built on 3 pillars. The first pillar, the chemical prison. Low oxygen levels and toxic water created a foundation that confined life to the ocean and set strict metabolic limits. The second pillar, the Cambrian explosion. On this foundation, evolution scattered thousands of building materials, an insane diversity of life forms. And the third pillar, the arms race. This confrontation between predators and prey became the architect that used these materials to build a brutal yet stable ecosystem. These 3 elements didn't just coexist, they amplified each other. This wasn't a random collection of monsters. It was a self-regulating system where every element, from calcium ions in the water to the shape of a predator's jaws, was in its place. In this system, the monsters weren't mistakes. They were perfect solutions. Look at them again, but now as keys perfectly fitting the locks of the Cambrian environment. Opabinia, its 5-stalked eyes provided a nearly 360-degree panoramic view in murky water, making ambushing it practically impossible. Its proboscis with a claw was the ideal tool for hunting on the seabed. Hallucigenia, its spines weren't oddities, but the simplest and most effective defense against predators that hadn't yet learned to breach such defenses. And Anomalocaris, its hunting of armored trilobites, was not an illogical waste of energy, but a brilliant strategy. It occupied the top of the food chain by specializing in the most challenging prey, where it had no competitors. These creatures weren't strange. They were the predictable result of evolutionary pressures. Their absurd appearance is merely a reflection of how different the rules of that game were from ours. And into this world, full of perfect solutions, enters a creature that possesses none of them. The jury, represented by the laws of Cambrian evolution, is ready to deliver your verdict, and it is final. First, chemical incompatibility. You would begin to suffocate within minutes due to the low oxygen content in the water and air. Second, biological defenselessness. You have no shell, no spines, no poison. Your soft skin is an open invitation for any predator. Third, sensory failure. Your sight and hearing would be useless in the murky, dense water. You wouldn't detect a threat until it was too late. And fourth, you are an ecological target. You are too slow and clumsy in the water, making you ideal, easy prey. Verdict, you would not survive. But it's not about your weakness. It's about the fact that you are a product of an entirely different evolutionary history. We are not the pinnacle of evolution. We are merely one of the surviving branches, fragile and adapted only to our own very specific moment in time. The Cambrian experiment is over. Most of its participants died out. But it left us with one fundamental question about the nature of survival. On one side, Anomalocaris. It embodies strength. It was the king of its world, a perfect killing machine, but it went extinct. On the other side, our ancestors, like Pikaia. They embody adaptation. They were weak, inconspicuous, but their simple body plan proved flexible enough to survive catastrophes and change. So what proved more important in the long-term perspective of evolution? Write just one word in the comments, strength or adaptation. There is no right answer. Let's just see what lesson most people have taken from this story, which happened 500 million years ago.